This is Algebra 2, Lesson 10.2, Probability Distributions. So we talked about histograms in Chapter 9. A relative frequency histogram is going to be similar. It's like a bar graph, but rather than showing how many there is in each bar, it's showing you a percentage relative to the total. So on a normal histogram, you might say 1, 2, 3, 4, 5, 6 going up the side, and whatever, bar shape you have would, follow in here. But instead of having 1, 2, 3, 4, 5 up the side, it would have maybe 0.1, 0.2, 0.3, and so on, representing the percentage of the quantities rather than how many of the quantities. Mean, median, and mode are things we've talked about in relation to data sets. Now, in relation to probability distributions, if you are going to find the mode of a probability distribution, you are looking for wherever the tippy top peak is, and then the x value related to that. Sometimes data sets have no mode, just like probability distributions will have no mode. If it doesn't have a pointy top higher than everything else, then there is no mode. A median would be wherever your data set is split exactly in half. If you have exactly half of your data on one side and exactly half of your data on the other side, then the x value that corresponds to that division point is your median. And finally is the mean. The mean is kind of complicated. To calculate the mean, you need to take the height times the midpoint of each column. Sorry, my screen keeps moving a lot. And then sum them. So that's how to do mean and how to do median and how to do mode. Let's look at a couple of examples. Use the probability distribution for each probability. So right here is my distribution. And in order to do probabilities, we need the number out of the total. So I'm going to get the total first because that's going to be relevant to all the problems. But if I count up how many boxes I see shaded, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These two boxes make number 19. This little triangle here fits in here perfectly. And then same thing down here, these two boxes make number 20. So we have 20 boxes altogether. So each of these probabilities are going to be something out of 20. So the probability that x is less than 2. Here is 2. So less than would be everything this way from 2. We're going to count up how many boxes are in this region. That's less than 2. And it'll be that out of 20. So that's 2, 4, 6, 8. 8 boxes out of 20. The probability that x is less than 2 is 8 out of 20. Letter B says the probability that x is greater than 4. Here is 4 right here, and greater than would be this way. So we're going to count all of the boxes in this region right here. Again, matching up partial boxes to make full ones. So we have 1, 2, 3, 4. 4 out of 20 is the probability that x is greater than 4. Letter C says, what is the probability that x is between 2 and 3? I think I'm going to switch so we can see this a little better. Here's 2, and here's 3. So between 2 and 3 would be this region right here. That is 4 boxes out of 20. And the final one is letter D, the probability that x equals 1. Well, here's 1. And remember, we've been counting boxes. So right now, as I shade this line, I am not shading any boxes. I'm actually shading a line, but that is 0 boxes. Anytime you have probability of x equal to a number, it's always going to be 0. Letter B, use the above probability distribution to calculate each measure. So I want to do the mode, the median, and the mean. Starting with the mode, I'm looking for a tippy top peak. And if I look at this distribution here, I have a flat line at the top, right here. And because that is not a point higher than the rest of the distribution, this distribution has no mode. To calculate the median, I'm looking for the vertical line that divides the distribution into 2 equal pieces. So that is not 3, just because it goes from 0 to 6 and 3 is in the middle. That is not the median. The median would be where we have 10 boxes on either side. Since I have 20 boxes altogether, I need 10 and 10. If I drew my line at 3, this gives me 12 boxes over here and only 8 boxes over here. And we are really looking for where we would have 10 and 10. So if I drew that center line at 2, again I'm at 8 and 12. So hopefully you get where I'm going with this. If we draw that line right in the middle of 2 and 3, right here, I'm going to count them up. We have 1, 2, 3, 4, 5, 6, 7, 8. These 2 halves make number 9, and these 2 halves make number 10. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my median is exactly 2.5. And the last one is the mean. Now the mean is very complicated. What we do is we take each of our vertical columns here. We take the height and multiply it by the midpoint of the column. Height times the midpoint, and so on, and so on, and so on, and so on. And when we have all of those, we add them together. So this is going to be 0.5 times 0.2. That's my first column, plus 1.5 times 0.2. That's my second column, plus 2.5 times 0.2. That's my third column, plus 3.5 times 0.2. That was my 1, 2, 3, fourth column. My fifth column now is 4.5 times, now the height here is actually 0.15. Plus, my last column is midpoint 5.5 times height 0.05. So that's 0.5 times 0.2 plus 1.5 times 0.2 plus 2.5 times 0.2 plus 3.5 times 0.2 plus 4.5 times 0.15 plus 5.5 times 0.05. The middle of each column times the height of that column, and then all of those answers added together. So I think I need to grab my calculator here.